Okay, so I just wanted to take a minute and finish going over the information for confidence intervals. Remember that we said you can only use a confidence interval for a two-sided test because we have our confidence interval that states where the true population mean could lie, and then that would be failing to reject the null if our population or null falls within that interval, and then we're rejecting it if it's outside that null. So when a two-sided significance test at a level alpha rejects the null, the confidence interval will not contain the hypothesized value. So if you create the interval and it does not contain your null, then you're rejecting the null. If you create the confidence interval and it does contain it, you're failing to reject the null. So just remember that your confidence interval always, so if you have if alpha is 10%, your confidence interval is 90%. So they're complements of each other. And when a two-sided significance test at level alpha fails to reject the null, the confidence interval will contain the mu. And that's basically what I just said. So if you create a confidence interval and the null is in the confidence interval, you fail to reject it. If you create a confidence interval and the null is outside the confidence interval, you reject it. You fail to reject it if it's inside the confidence interval. All right, so let's just take a look at the same break the ice game and see what it looks like if we do it with a confidence interval. So since our alpha level is 5%, the corresponding confidence interval is 95%. So we're going to calculate a 95% confidence interval. Does your interval support your decision from the test of significance? Now, keep in mind here we've already done the null and the alternative. We've already done the conditions. We've already done the state portion, so we don't need to redo all of that since that was already done in the first portion. And if you have a question that asks for that, you can always just say as stated in part 1 or something like that. All right, so let's see what the confidence interval looks like. Remember that it's still using your sample, so that's, like I said, the confidence interval for means and tests for means always use the sample, whereas proportions, the confidence interval uses the sample, but the test actually uses the population proportion. So the two for means are actually more strongly related. All right, so we have our sample mean here. Okay, you have your critical t-score, your sample standard deviation. Remember, this is our margin of error. This is our standard error. All right, what is the numbers plugged in? Here is our sample mean, our critical t-score. Okay, and remember when you do your inverse t, you're going to want to make sure you plug in the degrees of freedom. So here was our standard deviation, okay, and then here's divided by the square root of the sample size, or we could have just used the standard error and used it right here. That's totally fine too. Okay, there's our resulting confidence interval. So we're 95% confident that the interval captures the true mean width of cubes. Now, since 29.5, because that was our hypothesized null, is in the interval, we do not have convincing evidence to say that the mean is not 29.5. So since 29.5 is in here, that's one of the possible values that could be the true population. This actually supports our decision from the test of significance because we failed to reject the null for our test of significance. All right, so we're just going to go over how to use tests wisely and making sure that we have strong tests so that we can make inference to the larger population. So significance tests are widely used in reporting the results of research in many fields. New drugs require significance tests, significant evidence of effectiveness and safety. Marketers want to know whether a new ad campaign can outperform an old one. Carrying out a test of significance is often quite simple, especially if you use a calculator or a computer. Using tests wisely is not so simple. So here are some points to keep in mind when using or interpreting significance tests. Number one, the question is often how large of a sample size do you need? Remember that if you have a smaller significance level, that requires stronger evidence to reject the null, because a smaller significance level, so if it's 1% versus 5%, you're only rejecting it 1% of the time, and that requires us to have stronger evidence that it needs to be further away from the null value. A higher power gives a better chance of detecting a difference when it really exists. So remember, power is the ability to reject the null when we need to. If you have a higher power, if there is a difference, then we'll actually be able to detect it and reject the null. At any significance level or desired power, detecting a small difference between the null and alternative requires a larger sample than detecting a large difference. So if there's a huge difference between the null and alternative, then the sample size doesn't need to be as big because it's going to be obvious. But if there's not a large difference, but there is some sort of difference, then you want to have a larger sample size that will be able to tell us if in fact there is a difference, even if it is small. Okay. So the sample size is going to depend on those couple of things: the significance level, the effect size, and the desired power of a test. So the effect size is basically just how large of a difference between the null and the actual parameter is important for us to detect. So how far away does that sample actually need to be away from the null in order for us to detect that there is actually a difference, and the null, there's not enough evidence for the null. The power is what chance do we want our study to have to detect a difference that we think is important. So basically, if you want a smaller significance level and a higher power, you need a larger sample, because that's obviously going to be a better representation of the population. So sample size is really important in the planning process. Many studies fail because they have a lack of power, and this is something you as a statistician can help out with the planning process. Let's just take a look at an example on the next slide and see exactly how to answer these questions. So the superintendent of a large school district wants to buy a computer-based math program for his district. Because the program is very expensive, he'll randomly select some classes to pilot test the program. The response variable will be the average increase in grade level equivalent for the students in the class. For example, if a student went from 3.1 third grade 1 month to 4.3 fourth grade 3 months, by the end of the year they increase 1.2 grade levels. The hypothesis that the superintendent will test is the null is equal to 1, that's the same as going up 1 grade level, versus the alternative, which is greater than 1, so they went up more than a grade level in a year, where the mean is the mean, that should be a mu, where mu is the mean increase in grade level equivalent for classes in the district. To determine the number of classes he should use, he takes a look at the following. 1, the significance level. He wants to avoid a type 1 error. So that is keeping the null when it's false. So he wants to avoid a type 1 error and spending money on a program that doesn't work. Okay, so he chooses alpha equals 0.01. The effect size, a mean increase of 1 month, 1.1, would be important to detect. So he's saying that, okay, if it's greater than 1, a 1 month improvement is actually good, and that's not a huge difference between the null and what he's actually checking for. The superintendent wants a powerful test. He wants a probability of at least 80% that a test will detect an increase of 1 month in grade level equivalent. Okay, so what does it mean with statistical significance and practical importance? When a null hypothesis has no effect or no difference, it can be rejected at the usual levels. Alpha is 0.05 at 0.01, and there's good evidence of a difference, but that difference may be very small. So when large samples are available, even tiny deviations from the null will be significant. Also, just take a minute and beware of multiple analyses. Statistical significance ought to mean you have found a difference that you were looking for. The reasoning behind statistical significance works well. If you decide what difference you're seeking, design a study to search for it, then come up with a significance test to weigh the evidence you got. Okay, so in other settings, significance may have little meaning, so just make sure you're using the word significance correctly. All right, so basically in this section, what we did was we just did tests about a population mean. In the next section, we're just going to take a look at something called matched pairs, which you've heard about in experiments, and how they relate to tests about a population mean.